Now let's take a look at the method that R uses to check for errors within functions and some associated concepts that will help you write better functions. We are all well aware from previous experiences that we can make errors when we call a function. We've all had a chance to see error messages. It should be no surprise that we can also make errors when we call our own functions, and it should not be a surprise that we can make errors when we write our own functions. If we share our functions with others, then others can make errors when they call our functions. Let's take a look at some examples and some considerations for anticipating that users of our functions will make errors. Obviously, some of these are less important if we're the only ones that are going to use the functions that we write, but we might want to share these with others. Let's start by looking at how R handles errors that are within the functions we write. Here's a function with a purposeful error built in. This function, add5 or a, will add 5 to any number less than 10. If the number is 10 or greater, as you can see down here in my if-else, then it's going to add the character a, which of course is nonsense. So let's define that function. Let's call this with a number less than 10. So I'm going to add 5 to 8, 13. Now try typing this. Put in a number greater than 10. So I'm going to type add 5 or a 12. I got an error. An error in x plus a, non-numeric argument to binary operator. Now this error message that R has given me is actually pretty helpful here because it identified where it was in my function that things went wrong. But what I want you to notice is that when we defined this function, when I actually wanted to add it to the environment, it added it to the environment. I can see it here, add 5 or a. But what happened is that it did not tell me that it had an error message until it encountered the error. That is, when I tried a function call that worked just fine without error, no problem. When I tried a function call that did give me an error, that's when it told me there was an error. The point here is that R does not tell you when you load your function, hey, you have an error in your function. It doesn't even tell you for as long as the function is called without error. It only tells you there's an error when it encounters an error. We only obtained an error on the second function call. That is because R uses what is called lazy evaluation. Lazy evaluation means that the evaluation of your statement to see if it has an error is only made when it is run. It is not made when you actually write and load that function. This is some bad news because it means that when you write a function, you may not know until sometime later when some subtle error shows up that there is an error in the function, which is why people who write packages often have to keep revising their packages as more and more errors are found. Now, when we do think of the user sending us information that may cause an error rather than an error specifically in our function, it's good practice to insulate the users from errors. If a user provides a function input that they should not provide, we should tell them, and we should tell them in a way that they will understand. Anyone who's used R for any length of time knows that sometimes the error messages are very difficult to read, and it's very difficult to understand what is it really telling me. We got an error message a moment ago that it was actually pretty easy to read. It was pretty easy to identify, but of course, we knew we were putting that error in the function. We need to think about our users when we're going to give our functions to others to use in their scripts. Unfortunately, many R coders who share their code don't do this, and we end up with error messages that are difficult to interpret. Here's a function that will create a scatter plot and return the correlation. Creating a scatter plot and returning the correlation is really no big deal, and I don't know why I need a function for that, but I'm using it to present you how we might want to catch a couple of the more likely errors that people may put in. So notice on the if statement that comes first and the if statement that comes second, both of these are not really the heart of the function, but rather these are both for catching errors. And if you look at code in functions that are written even in base R, you'll see a lot of this. You'll see where errors are anticipated. So notice what the first one is. It checks to see if we have X and Y being numeric. And if not, we print a message, use only numeric variables when calling CorePlot. And then we return a null. In other words, we don't do it. If the length of X is not equal to the length of Y and we're trying to do a plot, we know that that's not going to work. So rather than letting the plot function give us some error that the user may not understand, I've added here my own error message. Make sure your vectors are the same length when calling CorePlot. And then later, after the error checking, I have the main guts of this, which is to plot and then return the correlation of X and Y. Notice that the error checking is the bulk of my function. When individuals who write code for a profession are writing for programs that many users will use, I want to let you know that this is not uncommon for the error checking to sometimes be even the bulk of the code, and then the actual performance of an operation might actually take less space like it did here. So here I'm going to go ahead and put my CorePlot function within my environment. I see it here in my environment. And first of all, let's call it correctly to see what it does. So I'm going to create two vectors, and then I'm going to call CorePlot. And so if I look down here, I see I got the correlation returned of 0.23, and I have a little plot that doesn't look like there's a whole lot of correlation, but a little bit of an upward slope from left to right. Let's do this. Let's create some problems. So now I'm going to create a vector that has characters instead of numbers. And now let's call CorePlot. Note the message. Use only numeric variables when calling CorePlot. Much nicer than if R had just given me that message. The message R gave me would be fine if it gave me this message, but it gives me something that's much harder to read. Now I'm going to do one in which I put in a vector 1 that's a different length than vector 2. So here's my vector 1. Let me go ahead and look at the lengths of these. The length of my vector 1 is 7, and the length of my vector 2 is 8. So they're two different lengths. Okay, let's go ahead and call CorePlot with that. Make sure your vectors are the same length when calling CorePlot. Note what I'm going to do here. I'm going to comment out all my error checking. And now look what happens when I call CorePlot. Let's see what I got. Oh, I've got to create my vector first. All right, I loaded the function. Now here's what I loaded, a function where all the error messages that I had put in there are commented out. All right, so we're going to put in a character vector. So we're going to type in this. I'm going to go ahead and just take these out for now and run it. Here's what it says. Error in xy.cores, xy, x label, y label log, x and y lengths differ. Okay, not too bad, except that notice that what mine had returned is to say you better just use numbers, which makes a lot more sense here. Let's do the other one. I'm going to put my little hashtags back in, and the reason I'm doing this is so that when I run all, it doesn't stop because of error messages there. Okay, now let me do this. I'm going to try it now with unequal length vectors. Here we go, my vector 1, run it. Error in x, y, notice that x and y lengths differ kind of makes sense, but notice that it gave the exact same message in both instances when the other one had not just a different length, but also it was non-numeric. So these messages are not as nice as what the messages were when we created them ourselves. R uses lazy evaluation, which means that you can put errors in functions and R won't know it until you actually run the function. R will return an error message at the point of the error. And functions that we write, especially if we're going to give them to others, can be enhanced with user-written error messages that anticipate the most common type of errors. I will tell you, in all honesty, that when I'm writing functions that only I'm going to use, I don't take the time to put in those enhanced messages. But when I write functions that are part of a package for, say, students in my classes, then I do include some enhanced error checking, especially in places where common errors are made. Obviously, it's optional whether you do this, but I'm giving you this as a possibility, especially if you decide that you want to write packages that lots of individuals might use.